So, guys, let's talk about machine learning. And what is this machine learning? It's basically a subfield of artificial intelligence that focuses on developing algorithms and models that enable computers to learn and improve from experience without being explicitly programmed. So the primary goal of machine learning is to allow computers to recognize some patterns and maybe some pictures, maybe some speech data, and make some predictions and make some decisions based on the data these algorithms are subjected to, much like humans do. So let's start with the very first important uh, parameter of machine learning is the data collection. So this first step in machine learning is to gather the relevant data that will be used to train the algorithms. This data can be in the form of structured data from database, or it can be unstructured data from various sources like text, images, audio, and video. Uh, so this is how the data collection is done, and certainly. Then this data needs to be processed. Once the data is collected, it needs to be processed and cleaned to remove any sort of noise that is there in the available data, or any kind of inconsistencies or some missing values. So data processing, it basically ensures that the input data is in suitable format for machine learning algorithms. And then comes the category feature engineering. Now, what is this feature engineering? Feature engineering, it simply involves selecting and transforming the most relevant features from data to train the model effectively. So this step is a crucial step, as the choice of features can be significantly impacted by the model of performance. Now, to take an example, suppose there is some kind of input that's given to the machine, and it is being subjected to some algorithm, and suppose we give two numbers to the machine to execute on. Now, suppose the answer that comes out to be the answer that is chosen by this algorithm is wrong. What is most important thing here is that we have to provide the feedback to the machine that this is not the right answer. So this is how the feature engineering goes on, where in cyclic loops these machines are trained. The algorithms that are out there, they are trained more effectively. And then comes the model selection. There are various types of machine learning algorithms, obviously, including supervised, unsupervised, reinforcement learnings. The selection of appropriate algorithm depends on the nature of the data and specific task that's to be executed. Now, the training of this model in supervised learning, say for example, if I take the supervised learning, the model is trained using labeled data, where each data point is associated with known output. So the algorithm learns from these input output pairs to make predictions on new unseen data. This is how these algorithms are trained. And then comes the evaluation point, and this is what we call as model evaluation. After training, the model's performance is evaluated. Once the model is trained, now it's evaluated using a separate set of data, and this data is called as test data, or test set. The evaluation matrix depends on the specific task, such as accuracy of something, precision, recall, or something else. And then comes model tuning. If the model's performance is not satisfactory, then hyperparameters and other settings can be adjusted to improve its accuracy and generalization. So it's like training a human being for performing a particular task. Uh, Not exactly like that. It's purely in classical sense here, and and these algorithms are taken through a range of steps, and finally uh, uh, there is tuning. There is the tuning of the model. If the model's performance is not satisfactory, then certainly there has to have some kind of improvisations to be made, so that such kind of deficiencies can be overcome. And then comes the model deployment. Once the model performs well on the test set, it can be deployed to make predictions on new real world data. So there is a training period. These algorithms are trained using some specific techniques. Well, experts are out there who are performing uh, operations, performing these kind of things on these machines, training them, and then trying to check whether the machine is in a position to predict, and if there are some leuconos available, then there is model tuning kind of thing. And once the tuning is done, then there is deployment of the model. Once the model performs performance is well tested, it can be deployed to make the predictions in the real world. And the next point here is model maintenance. So machine learning models require ongoing monitoring and updating to adapt to changing data patterns and ensure their continued effectiveness. So these are the set of some important points that are used over a course of time when these machines are trained to make predictions on the data which are there. They have never been subjected to. And then what are the possible applications of these machines? As we know that this machine learning finds applications in various fields, including natural language processing, image and speech recognition, recommendation systems, fraud detection, and autonomous vehicle movements, among others. It continues to revolutionize the way computers process and interpret vast amounts of data, leading to innovative solutions and advancements in numerous industries. So this is how the machine learning takes its course of time, and of course it's a very subfield of artificial intelligence. I should say a part within the artificial intelligence that is being exploited to move on